Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through everything you need to know about nonlinear relations. So we'll start with solving quadratic equations. So you always make one side of the equation equal to 0, then you either factorize and use the null factor law, or you use the quadratic formula. So here's an example of a quadratic equation. I will use the method of factorization. Whichever method you use, you have to first make one side of the equation equal to 0. So I'm going to subtract from both sides 5x, and I'm going to subtract from both sides 36. So now I'm going to factorize this. This is a trinomial, 1, 2, 3 terms. It's monic. The coefficient there is 1. So what we need to do is find two numbers that multiply to this number and add to this number. So those numbers go in the brackets. Those numbers are -9 and +4. -9 times +4 is -36. -9 plus 4 is -5. So the null factor law says either the first bracket equals 0, that would mean that x equals 9, or the second bracket equals 0, which means x equals -4, and we're done. Let's now look at the discriminant. So all quadratic equations can be written in this form: ax squared plus bx plus c equals 0. The discriminant is equal to b squared minus 4ac. The discriminant discriminates the number of solutions that the equation has. If the discriminant's negative, there are no solutions. If it's 0, there is one solution. And if the discriminant is positive, there are two solutions. So let's try this question. I'm telling you that this equation here, a quadratic equation, has no solutions. Let's find possible values of k. Well, we still need to make one side equal to 0. So what I'm going to do is subtract from both sides kx. Now I have an equation in the form ax squared plus bx plus c equals 0. Here, a is 3, b is -k, and c is 300. So the discriminant here is b squared minus 4 times a times c. Now, if this has no solutions, that must mean that the discriminant is less than 0. So tidying this up, -k squared is the same as k squared. And then 4 times 3 times 300, that gives us 3,600. That has to be negative. Now, factorizing k squared minus 3,600, we use difference of two squares. So I get two brackets, I square root the first, square root the second. In each bracket, one gets a plus and one gets a minus. So here I have something times something is negative. The only way that that is possible is if the smaller number, k minus 60, is negative, and simultaneously the larger factor is positive. So if k minus 60 is less than 0, I can just add 60 to both sides. I get k is less than 60. And here, if k plus 60 is greater than 0, I can just subtract 60 from both sides. So here, k has to be less than 60, and it has to be greater than -60. So in other words, it has to be between but not including -60 and 60. These are the possible values of k if this equation is to have no solutions. So the discriminant's important because it's used in the quadratic formula, and we'll look at that now. So this is the quadratic formula. X equals minus b plus or minus square root of the discriminant, which is b squared minus 4ac, all divided by 2a. I suggest you first calculate the discriminant. If I'm doing this one here, the discriminant is b squared minus 4 times a is just 1 in this case, times c. Here the discriminant is 4 minus 20, it's negative. So this equation has no solutions, there's no point continuing. As for this one here, well, one side of the equation is equal to 0, but I can't factorize. So the quadratic formula is going to help us. We will calculate the discriminant. It is b squared minus 4 times A times C. Now this gives us 13. Here the discriminant is positive. This equation therefore has two solutions. What are those two solutions? Well, they come from the quadratic formula. They will be minus b plus or minus the square root of the discriminant over 2 times a. So here there are two solutions. One is negative 3 plus root 13 over 2. The other is negative 3 minus root 13 over 2. And we're done. All right, let's now look at a harder quadratic equation. So even though this technically isn't a quadratic because it doesn't have x squared, instead it has x power of 8 and x to the power of 4, we can use what we know about quadratics to solve it. So what I'm going to do is solve it like a quadratic equation. I need to make one side equal to 0. So firstly, I have to get rid of this denominator by multiplying each side by the denominator. So I get x to the power of 8 plus 6. Now I need to multiply 2 by the denominator. I need to multiply 2 by x to the power of 4 and also 2 by 7. So making one side equal to 0, I get this here. Now it doesn't look like a quadratic, but the reason I can use the methods for quadratics is this is just this squared. So what I'm going to do is I'm going to let y equal x to the power of 4. Then y squared is x to the power of 8. I can rewrite this equation as y squared minus 2y minus 8 equals 0. So this one can easily be factorized. The two numbers that multiply to negative 8 and add to negative 2, they are negative 4 and positive 2. So using the null factor law, I get y equals 4 or y equals negative 2. But hang on a minute, y was x to the power of 4. So I want to find x, not y. So I have x to the power of 4 equals 4, or x to the power of 4 equals negative 2. Now this last one here has no solutions. You can't have an even power yielding a negative answer. This one here, you have to be careful. It has two solutions. It has the fourth root of 4, but it also has the negative of that. Negative fourth root of 4. So the fourth root of 4 is just the square root of 2. So the two solutions here, x is root 2 or x is minus root 2. All right, let's now look at graphing quadratic equations. So the graph of a quadratic equation yields a parabola. So the equation will either be written in this form, turning point form, or in standard form. So for turning point form, you can read off the turning point nice and easy. So here, the turning point is the negative of this, giving the x coordinate, and this one here just as it is the y coordinate. So the turning point of this parabola is 2, negative 1. To find the y-intercept, let x equal 0. So substituting x for 0, I can put that in my calculator if I wish, I get 3. The y-intercept is 3. Now to find the x-intercepts, we need to solve for y equals 0. So what I need is x minus 2 squared minus 1 equals 0. I have just taken this equation up here in white and changed y to 0. So I'm going to factorize this using difference of 2 squares. So this again is the difference of 2 squares. You square root the first thing, so square root of x minus 2 squared. You square root the second, 1. 1 gets a plus, 1 gets a minus. So tidying these up, this bracket will give me x equals 1. This will give me x equals 3. So the x-intercepts are at positive 1 here and positive 3 there. We also found that the y-intercept was 3 and the turning point was 2, negative 1 down there. So we've got enough to draw the parabola. It is going to look like this. Make sure you put arrows on either end. All right, let's do this one here. So once again, we can read off the turning point nice and easily. it is x coordinate is the negative of this number here, so -1, and then this number here as it is the y coordinate of the turning point. So the turning point here, -1, -2 is down there. Once again, to find the y-intercept, I let x equal 0. So I'm going to write the exact equation above, but everywhere I see an x, I'm going to change it to 0. So here I get -1 minus 2, which is -3. So the y-intercept is down there. Now, because of the negative there, that means that this parabola is going to be a frowny face like that. So this is the turning point. It's not going to go higher than that. This actually has no x-intercept, so there's no point trying to find them. We know what the parabola is going to look like. It's going to come up here, stop, and turn around at the turning point, and then we're done. Let's look now at graphing parabolas whose equation is in standard form. So here the equation is in standard form. Basically, it's expanded. So we can no longer read off the turning point, but we can easily read off the y-intercept. The y-intercept is just this constant here, so it's going to be 8. So there's the y-intercept. Now, when the equation is given in standard form like this, you use x equals -b over 2a to find the x-coordinate of the turning point. So it's negative, b is -6 over 2 times a. So we get x equals 3. So the turning point's going to be along this line here, x equals 3, but we need to know the y value of the turning point. So we substitute x equals 3 into the original equation. We get y equals, I'm just going to replace x with 3. So 9 minus 18 plus 8 is -1. The turning point is therefore 3, -1 down there. So to find the x-intercepts, we are going to let y equal 0. We're going to solve x squared minus 6x plus 8 is equal to 0. So we can easily solve this through factorizing. The two numbers that multiply to 8 and add to -6 are -4 and -2. So null factor law says either the first bracket is equal to 0, which would mean x equals 4, or the second bracket's equal to 0, x equals 2. So the two x-intercepts are here at 2 and here at 4. We know what the parabola is going to look like. It's going to come down and turn around at the turning point. Make sure you put arrows on the end. All right, let's now look at a harder question. So this question is a bit harder because we are going to find the equation of this parabola. So we don't know the turning point. We don't know if this is, 3.2 is the y-coordinate or 3.1 or whatever. So we're going to instead use the intercepts. So if a parabola has intercepts at -2 and 3, its equation will be of the form a times x plus 2 times x minus 3. Notice that in the brackets I had the negative of the intercepts. So intercept +3 and negative goes there. That's because I know that 3, when x equals 3, y has to equal 0. So 3 minus 3 will make that factor equal 0. So we're almost there. We just need to find a. So in order to find a, we need to use another point that can clearly be seen. So that point there, I can clearly see its coordinates as -1, 2. I'm going to substitute in x equals -1, y equals 2. I have y equals a x plus 2 times x minus 3. So I have 2 is equal to a times 1 times -4. So dividing each side by -4, I get a equals -1/2. The equation of this parabola is y equals -1/2, x plus 2, x minus 3. So if I'm asked to give this in general form, I need to expand. So I'm going to leave the -1/2 alone. Expanding using FOIL, I get x squared minus x minus 6. So the equation of this parabola is -1/2 x squared plus a half x minus 3. In other words, if I started with this equation down here, I would end up with this parabola. All right, let's now look at an application of parabolas. So we're going to solve this problem. 3 sides of a rectangular block are fenced using 40 meters of fencing. Calculate the maximum possible area. So let's start by drawing this. I have 3 sides of a rectangle, so maybe the house is here and facing that way. So what I'm going to do is define the variables. I'm going to call this side of the rectangle here x. Now, I don't want to call this one y because I'm going to have to end up solving an equation. We don't know how to solve equations with multiple variables. If this plus this equal 40, then this is 40 minus 2x. So the area we have here is width times length, x times 40 minus 2x. So expanding that, I get 40x minus 2x squared. Now this expression here, 40x minus 2x squared, that is a quadratic. We learned on the previous slide that the maximum or minimum value, parabolas always have one of those, never both, but the max or minimum value always occurs when x is equal to minus b over 2a. So here b is the coefficient of x, it's 40, and a is the coefficient of x squared, it's negative 2. So 2 times negative 2 goes on the bottom. Putting that in your calculator if you wish, I get x equals 10. So the maximum area occurs when this dimension here is 10. And that, of course, means this one is 40 minus 2 by 10. It is equal to 20. So because everything is in meters, the max area is 10 by 20 meters, which is 200 meters squared. You can't use only 40 meters of fencing and design a rectangle that has a higher area than that. All right, thank you so much for tuning into this video. Best of luck studying, but you'll ace it. This has been the luckiest maths teacher in the world. Have a great day.